So far, we saw the general definition of a power series. Using some examples, we saw that they converge or diverge for various values of x, which could be no values, which could be all values, or restricted values. As a theorem, it says that for a given power series of this form, Cn x minus a to the n, three things can happen. The series converges only when x equals a, because that makes it 0. The series converges for all x, which we saw in the previous example. Our third case is there's a positive number r such that the series converges if this is less than r and diverges if it's more than r, which, if I scroll back, was the case in the example where I had absolute value of x minus 3 less than 1. Radius of convergence, that's the number, which basically means that if I'm within that number, then I converge, right? Those are x values. For case 1, where there is only one point where it converges, then the radius is 0. If it converges for all x, the radius is infinite. The interval of convergence, that's a set of all values of x for which the power series converge. In the first case, it just contains a. In the second case, it contains everything. And in the third case, it contains, so if this is a, and r is the radius, so that's a plus r and a minus r. So it's symmetric. Let's look at an example. Find the radius of convergence and interval of convergence for this series. Again, resorting to ratio test, L is the limit n going to infinity of negative 3 to the n plus 1, x n plus 1, square root of n plus 2, n plus 1, negative 3, n, x to the n. This cancels out to give me a negative 3. This cancels out to give me an x. And maybe I'll write one more step. Negative 3x square root of 1 plus 1 over n, 1 plus 2 over n. This is basically 1. So I'm left with the ratio being, if you take the absolute value, I'm left with the ratio being 3x. Now for the ratio test for convergence, that's what I need. All right. So this means 3x is less than 1, greater than negative 1. X is less than 1/3 and greater than negative 1/3. So in this case, the radius of convergence is 1/3 and the interval is negative 1/3 to 1/3, because here a is 0. Find the radius of convergence and interval convergence of this particular series. Again, ratio test, limit n goes to infinity, n plus 1, x plus 2 to the power n plus 1, 3 to the power n plus 2, 3 to the power n plus 1, n, x plus 2 to the power n. It's 3. That cancels out to give x plus 2. So I'm left with limit n going to infinity, 1 plus 1 over n times x plus 2 over 3. That's 1. So my ratio is x plus 2 over 3. This has to be less than 1. So I get x minus negative 2 is less than 3, greater than minus 3. So there are a couple ways of solving this. The radius is directly 3. Interval is, so you can either use the fact that a is negative 3. So it's a minus r and a plus r. A minus r is negative 5 and a plus r is 1. Or you can actually just solve this in a regular fashion and get the values of x. So they're both valid ways of doing it. In the next video, we'll learn more about how these power functions or power series can represent certain functions.